Now we will quickly get on to little more important features called multi-threaded and object-oriented or 100% object-oriented. Yeah. So how can I explain multi-threaded? For example, let's say you have some task, yeah, which is supposed to be completed, and that task can be split into multiple subtasks. Let's say T1, T2, T3. Yeah. Let's say the task is what? For example, task is collect 100 names and then sort them and then make a list of it, sorted list. Yeah. Now this particular task, okay, I can, even though I can say collection of 100 names is one subtask, sorting them is another subtask, and then making the list of a sorted output is another task. Yeah. But these subtasks like T1, T2, T3, if I call it as like three different small pieces of work, they are sequential in order. Like I cannot sort, okay, before collecting the names, right? And similarly, I cannot make a list of sorted names before actually sorting them. So there is a dependency, like for example, sort is dependent on collection and similarly list is dependent on sort. So this is something called sequential order. Yeah. And whenever such task is there, I cannot actually do some parallel processing. Like I cannot hire three helpers, one to collect, one to sort, and one to list. Because if I hire three collectors, sorry, three helpers, yeah, still the second helper who is sorting is waiting for collector to complete everything, right? So they are forced to wait. Even though I have three different people to do this, second person is forced to wait till first person completes the operation. Yeah. But there could be some tasks. For example, let's say I have to complete something wherein I have to go and shop something. Okay. Similarly, I have to go and do some medical checkups. Yeah. And similarly, third one, I have to do some movie watching, for example. So three different uh, things I am supposed to do. Yeah. Now I can actually delegate or I can hire different three people. Yeah. And I can hire one helper who can do shopping for me. And similarly, I can hire another helper who can go and collect my medical um, uh, bills or receipts or reports, etc. And similarly, I can hire another person, helper, who can actually book my movie tickets. Yeah. And what I can do is I can ask them to go and then work independently. Yeah. Like for example, if this person takes 1 hour and if this person takes another 1 hour, if this person takes another 1 hour, in this previous case what happened is, okay, first 1 hour has to be done and then only second 1 hour can be done, then only third 1 hour. So you actually spent 3 hours in doing it. Yeah. Whereas here I can actually ask all of them to go and start doing it, and probably in 1.5 hours, okay, I can do everything. Like I can complete the receiving of shopping and everything. I can receive all the information from medical. I can also receive the movie ticket. In 1.5 hours, I have my all three work done. Yeah. This is because I have used three helpers to do it, rather than I myself going to shopping and then I myself going to medical stuff and then I myself going to book the tickets. Rather, I used helpers to do this. So this is what exactly happens in computer world also. So computers, yeah, our system, whatever you call it as, they will perform a task, and they will perform a task using a helper called process. In operating system, we have something called process. Yeah. And uh, operating system will also be doing different things, like for example, memory allocation, waiting for user command, some cleanup activities, some antivirus related thing. So many things it will be doing, right? So there are different processes. Similarly, for our program execution, like I have written a program and I wanted to execute the program, right? So for executing program also, it will have one process. Yeah. Now that process is like one helper from operating system point of view. I got one helper to do my work. Yeah. Now that one helper, if I assign different things to that one helper, right? That helper can only do it in a sequential fashion. He can only do it in a sequential fashion. So each one task, if it takes like for example 15 minutes, then the process will do first task 15 minutes, and then it will do second task, then it will do third task, then it will do fourth task, then it will do fifth task. Yeah, it will do sequentially. So that's why I take more time to actually complete it. Now I can actually make this computer, okay, to initiate a process, and then using that process, I can actually split that process into sub processes. It is like having one helper, second helper, third helper, and fourth helper. And each helper actually does this small work for me. And they can do in such a way they can actually synchronize. For example, when H1 is doing some work, yeah, and if he is little tired, then HQ can do that work in between. And then when H2 is waiting for something, then H3 can do something. Yeah. So like that, all these three worker utilize the time in a best possible way, resources in a best possible way, and literally do the work in parallel. So what we mean is computer also has resources, like for example CPU. For anything you wanted to perform, CPU is required. Yeah. Similarly, computer also has memories. So sometimes you need to store data, you need to read the data, etc. So you need memory. Like that, sometimes we use files to perform operations, etc. So these are resources, right? And these resources are limited. Like I don't have a CPU which is unlimited power, right? I don't have a computer with unlimited memory, right? They are limited resources, okay? But most of these resources are most of the time underutilized. Why they are underutilized? For example, our modern CPUs are very fast, yeah? But when I am writing a program, for example, I have written a program to accept two numbers and then add them and then show the result. Yeah. So here what happens, to accept the two numbers, I have to be dependent on user to input the number, right? The CPU is very fast, yeah, but user is slow. They will give you the numbers little slow. So when I'm waiting, like for example, when my program is waiting for users to number, CPU is actually idle. I can utilize that for some other work. That's what the concept of multi-threading or sub-processes or parallel processing. Yeah. So whenever resources are available idle, and most of the time they are idle because they are so fast, and in the real world that pace or the speed is very slow, so they are idle. So when they are idle, we can actually utilize their resources for other work. So that is what exactly a concept of multi-threading. And of course, C++ or any other languages, sometimes they doesn't support multi-threading by default, and you have to use an external library. Like in C++, I have to use an external library to have this parallel processing concept. But Java comes with multi-threading as a language feature itself. So I am not dependent on any external library or anything. I can use the language feature to write multi-threaded programs. What it means is, if I have a complex program doing a lot of different things and they are not dependent on each other, uh, then I can use multi-threading and I can have multiple threads. Thread you can imagine as like a simple process, a helper. Yeah, I can span any number of helpers. I can create any number of helpers and assign tasks to each helper and ask them to do it in a parallel fashion. And let JRE decide how to share the resources, everything. Yeah, so that comes as a Java language feature. Okay, but then it has its own limitation also. What is the limitation? Sometimes these helpers starts fighting for resources. Yeah. Now how to avoid that fighting? How to avoid a situation where one helper is waiting for another helper and this helper is waiting for this helper, like that? Yeah, that is what we call it as a deadlock situation. How to avoid it and everything? That is where JRE comes with an intelligent mechanism, so that we are not falling into such situation. Yeah. So not just supporting multi-threading feature, it is also supporting the problems, or it is supporting a mechanism to avoid problems with multi-threading. So that's exactly what Java's multi-threading concept comes into picture.